Hello viewers, Wagada now taking you through the tutorial for A-level subsidiary mathematics, and this video I'm going to go through the topic of quadratics and polynomials. So far this is the course outline for A-level subsidiary mathematics. Subsidiary mathematics is divided into three parts. The first part is pure mathematics, and there are 4 questions come in section A and 2 in section B, and these are the topics up here. Then mechanics, 1 question in section A, 1 in section B, and these are the topics. Then statistics and probability, 3 in section A, 3 in section B, and these are the topics. So in this video I'm going to go through these 2 videos of quadratic equations and polynomials. So a quadratic expression is in the form ax squared plus bx plus c, where a, b, and c are constants provided a is not equal to 0. So this one cannot be equal to 0, because if it is equal to 0, this term of x squared will vanish away, and you'll be left with this, which is linear. So a must never be equal to 0. Now let's learn something about factorization of quadratic expressions. So a quadratic expression can be factorized using the following steps. The first step is to find some 2 numbers or integers whose sum is equal to b. Remember, b is the coefficient of x, and product is equal to a times c, where a and c, this is the coefficient of x squared and this is the constant. So you find 2 numbers whose sum is b and product is equal to what is here times what is there. Then step 2, replace the constant b with the sum of the factors obtained. And step 3, factorize the expression by grouping the terms. For example, if they say that factorize the quadratic expression this, we shall go through the following steps. Step 1 was to look for factors whose sum is equal to 29 and product is equal to 10 times 21, which is 210. So those 2 numbers are 15 and 14, because when you add 15 plus 14 you'll come up with 29, and when you apply 15 by 14 you'll come up with 210. The next step is to replace this 29 with the sum of these 2 factors. Therefore, where there was 29, we shall put there 15 plus 14, and when you open this bracket, we shall come up with this 15x plus 14x. Now next is to factorize by grouping. So grouping means we pair two terms. So we shall pair this alone and also this alone. So if you look at the first 2, the common factor is 5x. So 5x, when I pull out 5x, here I'll remain with 2x, because 10x squared divided by 5x will come up with 2x, which is here. Then 15x divided by 5x will come up with 3, which is there. Then for these other 2 terms, the common factor is 7. So pull out 7, it means that 14x divided by 7 you'll remain with 2x, and 21 divided by 7 you'll come up with 3. Then from that step you realize that this and this is common, therefore you pull it out and remain with 5x plus 7, which is here. So in that case you will have factorized the given expression. So basically that is how factorization is done. Now we shall go to the second method we shall go to part B, which is solving quadratic expressions by factorization method. So now we have already learned how to factorize. So if this one is factorized to give you this, it implies that this quadratic equation, which is equal to 0, is the same as this. Now from there, what we shall do, we shall say that either this is equal to 0 or this is equal to 0, which is this step. Then after that step, you look for a way of making x the subject. When I make x the subject here, it will become negative p, and when I make it here, it will become -2. So basically that is how they solve quadratic equations using factorization method. The first thing is to factorize, then you split the two factors. But there is also another method of solving quadratic equations, and that is the method of using a quadratic formula. So consider the general expression, the general equation this, where a is not equal to 0. The quadratic formula used to solve this equation is given by x being equal to -b, remember b is here, plus or minus square root of b squared minus 4ac, everything divided by 2a. So this formula is very vital and is used to solve quadratic equations. So three cases may arise. One is that the whole of this may be greater than 0 or less than 0 or equal to 0. So if that is greater than 0, it implies that the equation has two real distinct roots. If it is equal to 0, it implies that the equation has repeated roots, and they're given by this formula, -b over 2a. Because the whole of this has gone away, so remain with -b in the numerator and 2a in the denominator. Then when this is less than 0, it implies the equation has no real roots. So because of its important role in determining the nature of roots, that this term is called the discriminant of the equation. So with that, now we shall go through some of the questions. Question 1 says, solve the equation this using the following methods: 1, factors or factorization, and 2, Roman 2, quadratic formula. So you start with part Roman 1, which is factorization method. Remember, the first step is to look for two numbers whose sum is -7 and product is equal to 1 times 10, which is 10. The sum is -7, product is 10, and those factors will be -5 and -2, because when you say -5 plus -2, you'll come up with -7, then -5 times -2, you'll come up with +10. Therefore, we shall come and say that now the factors will be x minus 5 and x minus 2. The reason why we're doing that is because here the quotient is 1. Therefore, when x minus 5 is equal to 0, x will be 5, and when x minus 2 is equal to 0, x will be 2. That is Roman 1. Roman 2, we shall use the quadratic formula. Now here we shall compare. Coefficient of x squared is 1. Coefficient of x is -7, and the constant is +10. Now that we have got a, b, and c, we shall first code the quadratic formula, then we substitute. When I substitute where there is b, I'll put there -7. Here b squared is that. Then a is 1, c is 10, a is 1. When I simplify, I'll come up with this. But remember, we have here plus or minus, so we shall first consider minus, then we also consider plus. So when we consider minus, it will be 7 minus 3 over 2 to give you +2, which is the same as this. Then consider the plus. 7 plus 3 over 2 is +5, which is also here. So any of the two methods is okay, whichever is simpler for you. Now we shall go to question 2. Question 2 says, find the values of k for which the equation this has repeated roots. So I think you remember the condition for repeated roots, the discriminant must be equal to 0. So what you're going to do, we shall first write this, then we cross multiply to come up with this, then we open brackets and rearrange by correcting like terms to come up with this quadratic equation. So for repeated roots, b squared minus 4ac is equal to 0. I think you remember that condition. Then next we shall substitute. Now b is this coefficient, which is negative k plus 1, and this is c, and a is +1. So we're going to substitute and come up with that. So here k plus 1 is common to both, so factorize it out. Here remain with k plus 1, which is here, and here remain with negative 4, which is here. Now this negative has gone because of this square. Simplify. 1 minus 4 is negative 3. Therefore, when this is equal to 0, k will be negative 1. When this is equal to 0, k will be 3. And that is what they wanted. So now we shall go to roots of quadratic equations. Consider the general quadratic equation this, where a is not equal to 0. If we divide through by a, our aim is to make the quotient of x squared equal to positive 1. Therefore, we shall divide through by what is here to come up with this equation 1. Other we shall start if alpha and beta, so this symbol is called alpha and this symbol is called beta, are roots of the equation 1 of this equation, it implies that x minus alpha is a factor and also x minus beta is a factor, and to be equal to 0. So when I open brackets, I'll come up with this. Then collect like terms. Here x is x, you'll come up with this. So we shall call it equation 2. Therefore, we shall come and say that equation 2 therefore becomes this. So from equation 2, this is what we get, because remember we said these two are roots, and alpha plus beta is called the sum. That is why you see a sum of roots, and alpha beta is a product. That's why you see a product of roots. So this expression is very vital, and we shall use it more frequently. Also, there's something we need to realize when you compare this with this. You realize that alpha plus beta will be equal to negative b over a, because here this is positive b over a and this is negative in brackets alpha plus beta. So when I take negative here, it will become negative b over a. Therefore, the sum of roots is equal to negative b over a, and the product will be c over a. When you compare this with this, they will be equal. So these three expressions we have put in box bracket are very vital. This one and also these two are very vital, and we shall use them more frequently in this part. So there are some expansions which you need to know before we go to the questions. One is, if they give you alpha plus beta squared, the first thing to do is to remember that this one is the same as alpha plus beta times alpha plus beta. Then I'm going to open brackets. Open brackets, it implies that this alpha multiplies through the whole of this to give you this, and this beta multiplies through the whole of this to give you this. Therefore, when I open brackets here, this times this gives you alpha squared, and this times this gives you alpha beta. Then here, this times this gives you beta alpha, and this times this gives you beta squared. So this and this are the same, therefore it will become 2 alpha beta. Then this one is here and this one is here. Now what we are going to do, this means that the whole of this is equal to this. What does that mean? It means that when I take this term, this side, I'll come up with this which is here minus this which is there, to be equal to this remaining part, which is alpha squared plus beta squared. So this is very, very vital. That is when there is a plus here. What if there was a minus? So you still go through the same procedure. If there's a minus, it means that this times this. Then this will multiply through this to give you this part, and this multiplies through this to give you this part. Now here there is a minus because of this. Now next is open brackets. So this times this gives you this, and this times this gives you that. Then here negative this times this gives you negative that. Then negative this times this gives you positive. Negative times the negative gives you a positive. But you already know here from above that this is equal to this. So what we are going to do, we are going to substitute, where we are going to substitute this plus this will be replaced by this. That is why you see a box bracket. that means that we shall remain with these 2, which is minus 2 alpha beta. So when I collect like terms, this and this will give me negative 4 alpha beta. So that means that the whole of this is equal to this. Therefore, to get alpha minus beta, I just put square root on both sides. So when I put square root here, it will become square root of alpha plus beta squared minus 4 alpha beta. Then also we need to remember the identity for difference of two squares. So alpha squared minus beta squared is equal to difference and sum. So with that, we shall go through these questions. Question 1 says, given that alpha and beta are roots of the equation this, express this in terms of P and Q. So the first thing to realize is that this one is equal to positive 1. Therefore, the sum of roots will be equal to negative of what is here. I think we saw that. Then the product of roots will be equal to what is here. That works only when here it is positive 1. I think remember that's why we first divided through by positive a. So now they want this. We remember we saw that this is the same as difference of two squares, sum, difference. And but we know that this is equal to this, so it's like we are going through what we have already done. So that means that when I substitute this, remember this one we already know that it's equal to this, so when I substitute I'll end up with this part. So from here we shall go and substitute. Where there is alpha plus beta, we shall put the negative p. Now negative p squared, it becomes positive. Then alpha beta is 2, but there is a 4, so there is 4 here and this 2. So now we have been able to get this. That means that to get alpha minus beta alone, to be square root, so we shall put square root here to come up with this, which is alpha minus beta. Then from there we shall remember that the given expression was this, which was sum and difference. Therefore, the good thing we already know the sum is negative p, so here we shall put the sum, which is negative p, and difference, which is square root of p squared minus 4q, and that is what they wanted. So now we shall go to question 2, which is that given that alpha and beta are roots of the equation this, show that this is equal to that. So the first thing to realize is that here the quotient is positive 1, meaning that the sum of roots will be equal to negative of what is here. That's why it's here positive, because negative of negative b will be positive b. Then the product will be here, which is c. Therefore, from the left hand side, this is the given expression. You want to show that this is equal to this, so we shall start with the left hand side and open brackets. So when I open brackets, this with this gives me that, this with this gives me that, then this with this gives me that, and this with this gives me that. So this one, the square can be put, the power can be put outside, and you put a bracket. Then these two, we already saw that is equal to alpha plus beta squared minus 2 alpha beta. I think remember that identity. Then this one, you maintain it. Then now shall substitute, because we know that alpha beta is equal to c. Therefore this you shall put there c, and here you shall put c. Then alpha plus beta is b. Therefore here you shall put b. But remember, the expression they want is this, so we have to simplify and see how we can get this. So the first thing to do is to rearrange. Bring this one this side to come up with this part. So this one comes here and this one goes here. Then from there you will realize that the whole of this is equal to c minus 1 squared, then plus this beta squared, sorry, this b squared. And that is what they wanted. Then now shall go to question 3, which says that alpha squared and beta squared are roots of the equation this. If alpha and beta are both positive, find alpha beta and alpha plus beta. So now here they have somehow interchanged, because we have been dealing with alpha and beta being roots. Now they have said alpha squared and beta squared are the roots. So that means that the sum of roots will be the sum of these two, which is alpha squared plus beta squared. And the product will be alpha squared beta squared, which is equal to 4. So I can pull this power outside to come up with that, then put square root on both sides to come up with that. Now here it would have been plus or minus, but they told us that the alpha and beta are both positive. That's why we take a positive value. That is Roman 1. What about Roman 2? Alpha plus beta, which has come and said that from this, we know that this expression is equal to this. So I'll come and substitute. Where there is this, I'll put 21. This is what I want. Then alpha beta is 2, so I'll come and put 2. When I take this one this side, I'll come up with this, then put square root on both sides to come up with that. And that is what they wanted. So now shall go to question 4, which says that given that alpha plus beta is equal to this and alpha beta is equal to that, form a quadratic equation whose roots are this and that. So for this and this as roots, it implies that the product will be this times this to give you this. So this cancels and this cancels to remain with positive 1. Then the sum, it means that you will add this plus this. So to add, you will get the LCM. LCM is alpha beta, which is here. Therefore, this divided by this, you get alpha. Alpha times alpha is alpha squared. Then this divided by this, you get beta. Beta times this, you get beta squared, which is here. But you already know that alpha squared plus beta squared is equal to this. So next we shall substitute, because we already know that alpha squared plus beta squared is equal to negative 1 over 3. So put it there. Then alpha beta is 2 over 3. So put it here. Then divided by, so this division sign is here. You divide by alpha beta, which is 2 over 3. So when I use a calculator, I'll come up with this as the value of the sum. Then from there, I'll code the expression of a quadratic equation. We already know that it's equal to x squared minus sum of roots times x plus product of roots equal to 0. So come and substitute. Sum is this and product is this. I can multiply followed by the LCM, which is 6, to come up with this, and that is what they wanted. So now I shall go to question 5, which says the roots of the equation this are alpha and beta. Form the equation whose roots are this. So for this, it implies that the sum of roots is. Now here realize that the quotient of this is a, so that means that the sum will be negative of this over this, which is here. I think you already saw that. Then that is the sum. Then the product will be this over this to give you that. Don't forget the negative on the sum. Therefore, we shall come out that for this and this as roots, sum of roots will be given by that. So I think you already saw that step in the previous question. So we are going to substitute. Where there is alpha plus beta, we shall put there this, which is here. Then alpha beta, we shall put there this, which is there. And also here. Now here I think you see that we are putting multiplication sign because we have got the reciprocal. So the division sign can change into multiplication sign if you get a reciprocal. So when I simplify, I'll come up with that, and that will be the sum. Now the product will be this times this, which will be positive 1, as we already saw. Therefore the new equation will be given by this form. Therefore, you shall come and substitute for sum and product. Then multiply followed by the LCM, and that will be the required equation. So now we shall go to remainder theorem and factor theorem. So if Px is given by this, where a is not equal to 0, then Px is said to be a polynomial of degree or order n. So we can use the word degree or use the word order to mean the highest power. So I think we realize that here it is x power n, so the highest power is n. That is what we call the order or degree of a polynomial in the variable x. So the remainder theorem says that if the polynomial this is divided by this, the remainder will be p alpha. Now where is this alpha coming from? It is got from by equating this to 0. So this to 0 implies that x will be equal to alpha. So that x, the value of x is what you replace here to get the remainder. Now in situations where we substitute for x and you get 0 as the value of p alpha, it implies that this will be equal to, will be a factor, meaning that there will be no remainder. So 0 means that there is no remainder, and when there is no remainder, it implies that this one is a factor, the one you used to divide. In that case, the remainder theorem becomes the factor theorem. So that is our heading: remainder theorem and factor theorem. So factor theorem is when this one is equal to 0, and remainder theorem is when this one is not equal to 0. So let's go through some of the questions. Question 1 says, if fx is equal to this, has a factor this, and has a value of 5 when divided by this, find p and q. Now here they talked about the word factor. Factor means there is no remainder, or the remainder will be 0. So here we shall come and first write this fx which is given, then we shall say that for this one, when you equate it to 0, like we said, you realize that x is equal to 2. So what I'm going to do, I'll put 2 where there is x. So I'll come up with f2, and here 2 cubed will be that, and this will be that, this will become that. So in the end, when I simplify, I'll come up with this equation 1. They also told us that x is equal to 3 has, when divided by this, the remainder is 5. Therefore, when I put negative 3 where there is x, I'll end up with 5 as the remainder. That's why here you see 5 and not 0. So here it was 0 because this was the factor, but here we put 5 because it's what was given. So when I simplify, I'll come up with equation 2, which is that. Now I've got 2 equations and 2 unknowns, so I have to solve them simultaneously. When I subtract 1 from 2, I'll come up with, for example, 9p minus 4p gives me 5p. Then this minus this, it cancels. Therefore, 17 minus 2 gives you 15. Therefore, when I divide both sides by 5, I'll come up with p equal to 3. Then from equation 1, I'll come and substitute for p and make q the subject, and q will become negative 10. So basically that is what they wanted. Now we shall go to question 2. Question 2 says, when fx, which is this, is divided by this, the remainder is 2, and this is a factor of fx. Find the values of a and b. So first of all, fx is that, and when divided by this, it implies that we shall come and equate this to 0, then get the value of x, which is negative 1. So where there is x, we shall put the negative 1 to come up with fx negative 1 being equal to this, and in the end we equate it to 2 because we are told the remainder is 2. So I'll simplify to get equation 1. Then next they told us that this one is a factor, meaning the remainder is 0. So when this is the factor, x will become negative 2. So come and put negative 2 here and here to come up with, I think we realize that we are equating it to 0 because they told us it is a factor. So when I simplify, I'll come up with equation 2, and these 2 equations have 2 unknowns. Therefore, I have to solve them simultaneously. Therefore, equation 2 minus equation 1, I'll come up with this. So this is equation 2, and this is equation 1. So subtracting the 2, this cancels, and here I remain with a. Here 8 minus 3 give me 5. Now from equation 1, I'll come and substitute for a and make b the subject, and b will become negative 2, and basically that's what they wanted. So now we shall go to question 3. It says that the expression this is divisible by this, meaning that this is a factor. So this word divisible means that it leaves no remainder. Therefore, this is the factor, and has a remainder 8 when divided by this. Find the values of a and b. So we shall first let px be equal to that polynomial. Therefore, we are told that this one is divisible by x minus 1, meaning that x is equal to 1. Therefore, p1 will be equated to 0 because it was divisible. The next is x minus 2. X minus 2, it means that x is equal to 2. Therefore, p2 will be equal to 8 because they told us it leaves a remainder 8. Now, those are two equations and two unknowns. We shall solve them simultaneously. Therefore, equation 2 minus equation 1 will give me that. So this 128 minus 1 gives you 127. Then 8a minus a gives you 7a. Then 8 minus 0 gives you 8. When I make a the subject, a will be equal to negative 17. Then from equation 1, come and substitute for a to get the value of b as 16, and that's what they wanted. Then question 4 says the polynomial this has factors this and this. Find the values of p and q. So you come as that, let p be equal to this. They told us these are factors, meaning the remainder will be 0. So when I substitute x equal negative 1, I'll equate it to 0 because they said it's a factor. Simplify, come up with that. Therefore, equation 1 will be that. Then for this one, they said it's also a factor. Therefore, p negative 2 will be equated to 0. So I also have to simplify. So when I simplify, I'll come up with that, and therefore equation 2 will be that. So these are two equations and two unknowns, so I'll come and solve them simultaneously. Now equation 2 minus equation 1 will give me 3p equal to 12. Therefore p will be equal to 4. And from equation 1, come and substitute for p to get the value of q as negative 16. And that's what they wanted. Then question 5 says, given that this and this have a common factor, find part A the factors of this, and part B the value of A in that. So factors means that we are going to factorize. So I think remember the procedures for factorizing. You look for two numbers whose sum is positive 7 and product is this times this, which is negative 8. Those two values are positive 8 and negative 1. Therefore, where there was 7, you replace it with 8 and 1. That's why you see here 8x minus x. The next is to factorize by grouping. So factorizing by grouping, these two I'll come up with this, and these two I'll come up with this. So this and this are common, so we put them out to remain with 2x minus 1, which is here. In that case, we shall have factorized. Then for this one still, you look for two factors whose sum is positive 3 and product is negative 4. That is positive 4 and negative 1. That is why you see where there is 3x, we have put there 4x minus x. Then grouping, this one alone factorizing gives you this, and this one alone factorizing gives you that. Now this and this are common, so pull it out and remain with x minus 1, which is here. So in that case, we have also factorized that, and we have done part A. For part B, remember they told us that all these three expressions have a common factor. Therefore, in these two, it is this one which is a common, therefore implying that even in this other equation, x plus 4 is also common. That we shall come and conclude that the common factor is x plus 4. Therefore, let fx be equal to this. And using this other factor, it implies that x will be negative 4, so come and substitute for negative 4 and equate to 0 because it is a factor. Simplify and make a the subject. A will be equal to 26. And that's what they wanted. So that brings us to the end of this video. Thank you for watching, and be reminded that next video will be on matrices. So If you have not yet subscribed, please click on the subscribe button below this video so that you can receive updates when the next video on matrices has been uploaded. Otherwise, thank you for watching, and also if you know of any student who's not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp so that we can all benefit as a family.